Okay, Kathy Cottrell, thanks so much for being here, or thank you for having me today.
Thank you for coming. Thank you.
At SNC.
We welcome you. I'm glad you're here.
Yeah.
Thank you.
Thanks. So you're Senior Director for
Yes.
Product Development at SNC Lavalin.
Yes, I
And
am.
that's the nuclear sector of SNC.
That is correct,
Because SNC is a
yes.
huge company.
Yes, it is.
But from
Perfect.
this building, it seems like nuclear is pretty big too.
Nuclear is very big, and especially in Canada, because we have about 60% of our power being produced by nuclear just in Ontario.
Oh, wow.
But
60% of your power or your clean power?
Nuclear is clean power, but 60% of the total power generated.
Total power. That's
Yes.
amazing.
Mm-hmm. It's very good. And we
Yeah.
are a part of this, a major part of it.
Right.
Mm-hmm.
And how did you get in the nuclear field? So you started off in chemical engineering?
I did.
believe?
So I completed a PhD in chemical engineering.
Cool.
And I was just telling Catherine, my colleague, that one of the gentlemen here interviewed me in university and offered me a position. So I can't say that I really knew a lot about nuclear, but I've learned a lot in the 22 years I've been here. And I've really enjoyed my experience here.
So you got out of your PhD and then what, you were just looking for a job and so someone referred you here?
Yes, well, I do have my relatives up at our Chalk River laboratories that worked there. So I did know about nuclear a little bit,
Yeah.
but once I got the opportunity, I took it.
So how did you go from, being an expert in chemical engineering to actually getting over that steep learning curve in nuclear?
I worked really hard, but I think that our learning in engineering allows us to learn when we get a job in the real world, if I can say that.
Yeah.
And our chemical engineering principles are applicable to nuclear as well, because we have a lot of process systems.
Yeah.
So I was able to use that knowledge in my work here.
Yeah, which I'm happy you mentioned because of the room that we're in illustrates this culture of learning here and systems dynamics, because we're in a, simulated control room for a CANDU 6 reactor, which is pretty cool.
It is really cool. And that's one of the things here, we're constantly learning.
Yeah.
So you can go from many different areas within the company, and every day you're learning, be it through training, be it through the work, or just interacting with our colleagues, because we have really the most highly educated colleagues here, and we learn so much from each other.
Yeah, it seems like a great work environment.
It is really a great work environment. I'm very lucky.
Yeah, so how long have you actually been at SNC for now?
So I've been at SNC Lavalin for 22 years.
Wow, that's amazing.
Yes.
It's almost my whole life.
Yeah, I started when I was 10. I'll tell people that.
Yeah, you're a millennial.
Child prodigy, exactly.
And so what was your first role at SNC?
When I first started, I was working on an isotope production facility.
Cool.
So I was a process engineer, and we had to design the facility for extracting the isotopes. So we would help them to make medical isotopes that are used for diagnostic medicine.
Yeah,
Mhm.
that's pretty
Treatment.
interesting.
Yeah, it was very interesting. As my first job, I really learned a lot.
Yeah, and so, how did you then gradually get into the company, into more of like the product development side?
So my first opportunity was looking at fuel cycles.
Okay.
So the CANDU reactor is quite unique in that it can use spent fuel from other reactor types to generate power in the reactor, the CANDU reactor. So our first job was to look at something with our Chinese colleagues, because we have two CANDU reactors in China.
And I guess before you go further, in case this is somebody's first episode,
Yes.
want to go through what a CANDU reactor is and what the name means?
Okay, so CANDU is Canada Deuterium Uranium Reactor. So other reactor types used enriched uranium. Our CANDU reactor uses natural uranium, so what comes out of the ground. And due to the physics of our reactor, in order to make the natural uranium reactor run, we use heavy water. So we use heavy water in our reactor because we're using natural uranium.
And so is the sort of drive to switch from enriched uranium to natural uranium because maybe with natural uranium there's less of a risk of like having to look at the level of enrichment and make sure it's like safe and nobody can make a dirty bomb from it, or what's the
I think the
motivation?
driver for using the natural uranium is Canada has a lot of uranium and it's right from the ground, so we're able to use that directly.
Got it.
Yes.
And you guys have a mining sector of SNC Lavalin. Do you guys mine your own uranium? and then use it in your nuclear?
So we are just the designer or the vendor.
Right.
So we don't actually own a reactor and run it. We sell our design to nuclear utilities, and they would take care of that process.
Yeah, so you guys are just sort of the brains behind the reactor design.
Correct, that is correct.
Perfect.
The original equipment manufacturer,
Wonderful.
the OEM. Mm-hmm.
Yeah, okay, and so we were talking about the CANDU reactor and using more advanced fuels
Right.
for the CANDU reactor.
Right. So in China, we have 2 CANDU reactors, and our Chinese clients were thinking of other ways to utilize other resources in their fuel plant, because unlike Canada, they don't have a lot of uranium in China. So they do have a lot of the other reactor types, which is the pressurized water reactor. And because of the characteristics of our CANDU reactor, we can take the fuel that has been already used in a pressurized water reactor and use that in our reactor.
Cool.
So it's really great because we're recycling that fuel and getting more energy out of that fuel.
Yeah.
So we did some work with our partners, and we developed a fuel that could be used in the current reactors. We tested that fuel. We looked at it, investigated it after it came out of the reactor, and we found that it behaved exactly as we had predicted. Cool. So we could use that in place of natural uranium in the CANDU reactors.
And what's the characteristic of the spent fuel from the pressurized water reactors?
What do you mean the characteristics?
Like, help me visualize it. What form is it in? How enriched is it still?
So the reactor, we put the uranium fuel into a fuel bundle, which is about 1/2 meter long. So this goes into the reactor, and that same fuel bundle comes out of the reactor that way.
Okay.
And we safely store that in a spent fuel pool. And after a period of decay, when it cools down a little bit, we have also designed and built safe storage for the fuel bundles. So everything is stored on site and monitored and controlled.
Yeah.
Yeah.
So then, okay, I'm gonna ask you some tricky questions.
Sure.
And maybe they won't be tricky.
We'll see.
So
we'll see.
If we start building more heavy water reactors, less pressurized water reactors, should we still be investing in trying to recycle the waste from the pressurized reactors? Or should we, maybe just focus on making a closed-loop system only with heavy water reactors?
Ideally, I would love that you did that. One of the other things that we can do with the CANDU reactor is we can use thorium. So thorium is about 2 to 3 times greater in occurrence in the Earth. So there's way more thorium out there. And our CANDU reactors are the best reactor that can be used for utilizing thorium fuels. So that's another instance. But I believe that all reactor types are important, and just having the synergies between them allow us all to work together, and it also helps to close the fuel cycle.
Yeah.
Right?
Yeah. So I guess you spend most of your time right now working on the fuel cycle, right? And looking at the different types of fuels?
Right. So one of the things we did, because we were successful in showing that the CANDU reactor could use advanced fuel cycles, we put that into the development of a new reactor, the advanced fuel CANDU reactor.
Okay.
So we wanted to take the capability of the reactor and even get more utilization out of the fuel.
Is that efficiency of the fuel, basically?
Pretty much, let's call it efficiency, so extra burn up that we get out of it.
Okay.
Yes.
Cool. And it's advanced because it uses recycled material?
That's right. It uses advanced fuel cycles. So we could use the recycled material, or we could use thorium fuels.
Okay. So it could be either.
Correct.
Because I was going to say, why don't you call it like the recycle?
Exactly. Yeah, nope, just advanced fuels.
Okay, and has this, how do you guys test this? So obviously you have like test rooms here. Can you test different fuels through this test room, or?
This is just used for simulation and really for learning and training. If we, depending upon the fuel type that we pick, we would have to test the fuel to get, let's say, the physics properties or the physical properties of it in a research reactor.
Okay.
So at Chalk River Laboratories, we have a research reactor, so we can do controlled testing, get the data, and that data will help us to verify and validate the work that we do here in design.
How big is your guys' test reactor at Chalk River?
I couldn't tell you. I don't, like how many megawatts? I don't even know how big that is, but
okay.
Yeah.
No, that's fine. I'm just wondering sort of how it compares to in the US, how we test our fuels and how we test new products and develop them. Because in the US, it's really hard to actually get the financing to test large projects and to test these new technologies and new ideas. And so how does, it work with funding and regulations in Canada to get a product tested and ready for market?
So of course, we have to show that we have a client that would like to purchase it. So we do have partnerships with our clients, and they enable us to do that. They also, SNC Lavalin they're very engaged in innovation. Yeah. So they ensure that we do have a healthy product development budget to help us get to those next stages. So those means have enabled us to drive our product forward. And of course, we have to meet all of the regulations and requirements, and we work closely with the regulatory authorities to ensure that we're meeting all the standards required.
So are most of your customers government customers, or are they more private funder?
They're mostly government clients.
Yeah.
Yeah.
Because having 60% of your energy come from nuclear, it seems like the government is pretty invested in the nuclear space.
Absolutely. And I don't know if you've seen in Ontario, but we are undergoing some refurbishment projects. So we are extending the life of our reactors. And so the Ontario government is very invested in this and has put forward the funding in order to ensure that that happens, so that we keep our lights on and we can have this meeting in this beautiful room.
Yeah, it's amazing. And I was gonna ask you about fuel, recycling the fuel. Okay. Right now, I guess it depends on where the plants are, but what do you guys do with the spent fuel from the pressurized water reactor? Was it just to safely store it on site for right now?
That is correct. And sorry, in Canada, there is an undertaking from the Nuclear Waste Management Organization, and they are undertaking a process right now to find a deep geological repository for the fuel. So they are going out to various communities to see their interest, and they should be selecting a site to have the deep geological repository.
Interesting. Yeah. And so what are the communities? How are their responses?
A lot of them are getting in line to take on this opportunity.
Oh, really?
Yeah, they're embracing it and are welcoming of it.
That's great to hear.
Yeah.
And so kind of your personal take on it, do you think that we should do that? Because if we could use it as recycled material, you wouldn't want to then go back and undig it from the geological site?
Of course. Our spent fuel, because we start off with something that is natural, has a very low enrichment. Okay. So we probably could not reuse that fuel in a reactor.
Can you say that again? Sorry.
No. So it has a low enrichment when it comes out of the reactor, so we probably could not reuse that at this time.
Okay. So then what are you using to do the testing?
So that comes from a different reactor technology. Okay. So they use a higher enrichment. So when it comes out of their reactor, it is still high enough to use in our reactors.
And it's coming out of the pressurized?
Correct. And we're a pressurized heavy water reactor.
Okay. Yeah. But you guys, so in Canada, you don't have pressurized water reactors?
We don't.
Why not?
Because we have the CANDU and it's the best. We don't need another technology.
That's so funny. That's perfect. Yeah. And so then, okay. So you're looking at, sorry, I'm trying to wrap my head around this. I have like this picture forming in my head of like a global scale application of the advanced fuel. So when you are testing, reusing the fuel from pressurized water reactors, that's sort of in the scenario that you guys install a CANDU reactor somewhere where they already have pressurized water reactors. And so in that way, like whatever country you install it in could have a closed fuel cycle, but it doesn't necessarily imply in Canada where you're focused more on the thorium.
Exactly. Okay. So primarily that's has been our driver. So for every 4 PWRs, we would build 1 CANDU.
Oh, wow.
I know, isn't that cool?
That is really cool.
Yeah.
And so, but it's in testing now, so you haven't been able to bring it abroad yet, or are you testing it abroad as well?
We are primarily focused on working with China to bring this to China because they have such an enormous fleet of PWRs. But we would be more than happy to take it to the US as well, because you have quite a few PWRs.
I mean, personally, I'd be happy to take it.
Exactly.
Convince our
we
government.
need to work on that.
Yeah, we need to work together.
Exactly.
Yeah. Okay, and then how do you market nuclear as a product on the topic of selling it to the US? Because this is a huge problem that we have in the US. We don't know how to sell nuclear to the public, and we don't really know how to sell it to people who would invest in the testing. So what's your kind of secret to CANDU and advanced technologies of how to sell?
So the CANDU technology is one of the best performing technologies in the world, and we have been working at it over many years when other reactor vendors have not been advancing it as much. We just have to keep demonstrating that it's safe, which it is, that it provides clean energy. I think that's always a misnomer, that nuclear does not provide clean energy, but it does. And that we safely store all of our spent fuel, and we monitor it, and we take care of it till the end of its life. Whereas I don't think we don't emphasize enough that we are taking care of that waste or spent fuel, whereas other industries, they don't have a solution in my mind. So I think we need to just be more forthcoming of what our technology can do and the benefits that nuclear brings.
Yeah, that's so interesting, because it kind of sounds like the 3 points that you hit are like the main arguments that people have against nuclear. So you're saying just sort of defend it by facts.
Exactly, because I don't think the facts get out there all the time. And I think we just need to keep promoting it.
Yeah, and have you found that there's a profound difference in terms of how people see the CANDU technology when you're selling it to different markets, like within, I guess you don't really have to push to sell it in Canada, but selling it to China versus selling it to another country?
They see the benefits of it. A couple other things that make us unique are that we can use the fuel cycles. So we can use different fuels from different reactors. We can use thorium fuels. We can also produce isotopes in our reactor. So for food and just for the food industry and pharmaceutical industries. So at cobalt-60.
Okay.
So this helps if you want to sterilize something, you would use this isotope in the sterilization. So that also adds a great benefit to the reactor, as well as we can disposition other actinide wastes. So there's many benefits beyond power generation that the CANDU reactor can bring to a country.
Yeah, and I guess that's the cool thing about your job, is that it's not just unique to the energy sector, right? Because SNC is nuclear and not nuclear energy.
Exactly.
Yeah.
And we do so many different things, and it just keeps every day exciting.
Yeah. So on that note, what do you think has been one of the most exciting projects you've gotten to work on, if it's not this?
Well, it is the fuel cycles, because it was the first time we were able to put a new fuel into a reactor and demonstrate that it behaved as we expected, and then take that further and implement it into the whole reactor.
So how long is this timeline of you guys conceptualizing the idea and putting it through the testing?
So it took about 3 to 5 years to do that.
Quick.
It was really quick. We did a really good job.
Yeah,
exactly.
You guys sound flawless right now.
Well, we're not flawless. There were lots of challenges that I won't tell you about, but we embraced those challenges and we worked together to resolve them. And we had a really good partner in China, because they allowed us to use their CANDU reactor to test the fuel.
Okay, so you were testing it in China.
Correct, in our CANDU reactors.
Interesting.
Yeah.
And so were they Chinese clients then, because you were testing it in China?
Yes.
And so have they approved it for use on full scale yet?
Yes.
And has it been used at full scale?
It hasn't been used yet, but they will be implementing it soon.
Okay. What's soon?
I don't know their timeline. I would have to go back and check with them.
Oh, okay, so it's like passed off to the client now.
Yes.
You guys are. And so what's next for you?
So now I'm the Senior Director of Product Development. So we're looking at more products.
This was all before you were Senior Director?
Yes.
Oh my gosh.
I had to keep busy.
You did.
But now I'm looking at all of the products that we develop at SNC Lavalin in Canada.
Okay, so what are some of the up-and-coming products?
So some of the up-and-coming products are, we have a cable tester. So we can go into a plant and we can test the electrical cable without having to shut down the reactor or shut down anything. We could do it all online, and we tell you the health of your cable.
Cool.
So it's really cool. It helps save money because utilities may have had to pull that cable to change it, whereas it was perfectly healthy to keep their plant running safely. So they can put that off or determine when they can change out that cable in their next outage. So it's not a surprise when the outage comes up and they find out they have to change it.
And so what's the difference? Is it like a physical thing that you put on the cable?
Yes.
And it's called, how does it work?
So it just presses it in, and by the response time, it can tell if it's brittle or not.
Huh.
Yeah.
So it just continually presses down on the cable?
Yeah, so you would go in and you do it one time, and then, and you get the measurement from that.
Okay.
So you go in periodically and assess the cables.
Why didn't this exist before?
I guess it's been an evolution. So it's been an evolution over many years and different people do it. But ours also has a unique benefit that we can test the recovery time. Not all cable testers do that. So you measure the recovery time when it bounces back out.
So it undeforms,
exactly.
Basically.
And this is a better indicator of the aging of some cables that are maybe making up about 70% of what's in the plant.
Wow,
so
70% of the plant is cables.
Well, no, of the 70 of all the cables in the plant, 70% of them are this type of cable that RT or recovery time gives a better indication of its health.
Got you. Cool.
So it is pretty cool.
How often do you have to check cables?
I think they do it I think that it depends on the cable, but every 2 to 3 years.
Okay.
Something like that.
So would someone literally just walk around with this?
They would walk in, yes, and it's all a handheld device and they can just walk through the plant.
Cool.
Yeah, you'll have to link it to our video once we get it up.
Yeah.
Yeah,
absolutely.
I'd love for you to do that.
So then it's already out there as a product?
Yes.
And how's it doing?
It's doing great. We've had great reviews and people are happy with the work that we're doing for them.
Yeah. So on that note, how long do you sort of see a project out till? You know, you have your product and it sells to certain customers. How long do you monitor how well that product did and keep selling it for?
For as long as there is interest.
Yeah.
So I would say over like at least 10 years. But we also have to keep our eye on the market and see if that technology is still relevant. Right. And if not, how we can modify it, improve it, get feedback from the customers, and put that into our products.
Yeah. And so how many products do you manage?
I would have to count them all. Let's say roughly 20 right now that are under development.
Okay.
We do have a big investment right now in our retube and refurbishment tools. So you'll talk to Rob Malazzi later on and he'll tell you all about it. But because it's such a large undertaking in Ontario right now to refurbish all of our plants, we want to make sure we have the best tools available for our client in order to ensure that we meet the schedule, come in under time, come in under budget.
Yeah.
So we are continuously investing in those retube and refurbishment tools to give our client a better tool to complete their jobs.
Yeah, so that's a lot of projects to manage. What would you say is the oldest?
The oldest
product that you have?
The oldest product, well, probably our CANDU reactor because that was our original product. We first built them back in the 70s. That's why they're undergoing a refurbishment right now.
Yeah.
So that was something that we developed, I'm going to say from scratch here in Canada, and we've been able to sell it all over the world. So that investment has really paid off for us. And it's still one of the best performing technologies in the world.
Yeah. And so now, 30 years later or so, it's time for refurbishment. And it's time for refurbishment because your guys' licenses go out to like 30, 40 years. And then you have to get a renewal.
I think the licenses are renewed periodically along that time.
Yeah.
But in terms of the retube and refurbishment, we change out the reactor core. So the reactor core has a specific design life, and depending on how it behaves during the life of it, the tubes that are within our reactor core need to be changed out because their life has come to their design life end.
Yeah. So that's a huge job.
It is a huge job, but we've done it in many countries. We just completed one in Argentina because we have a reactor in Argentina, and that was successfully completed.
Was that the first one that you did? Or?
No, we've done many. So we've done it in Point Lepreau in New Brunswick. We've done some at Bruce. We've done some in Korea and Argentina was our latest one. But now we're currently undertaking the refurbishment of the Darlington units.
And how long, how much testing do you guys have to do on your end to, know that you can safely replace the tubing in a core?
It's a great question, and Malazzi might be able to answer that better. But it does go through stringent testing that we do in our laboratory. We have a laboratory over in SP3 in another one of our buildings here, and they have mock-up facilities. There's extensive training, and we learn from all of our refurbishments.
Yeah.
So everything that we learn, we take that feedback and operation experience and feed it back into our designs.
Yeah, have you guys ever had a refurbishment that maybe threw you a lot of challenges?
I think everyone throws us challenges, but I think we have a really an expert team, and they are capable of taking those challenges.
Yeah, and so let's talk about your team. Are you guys segmented into different sub-teams?
For the product development?
Yes.
So, yes. So I control the budget and what is being done, and I farm out, if you will, the funding and the work to the various areas that are experts in those areas. So for example, I would give the refurbishment tooling. If we're going to do some modifications, I'd give that to Rob Malazzi. So he would undertake that work on my behalf and see it to completion.
Cool.
Yeah, it's really cool.
So there's Rob. Are there any other, for refurbishment, what are the other sort of sections of your product development?
So there's new design. So we continuously look at new design features that we can incorporate into our new build reactors. So there's many different people that work on different areas such as civil engineering, process engineering, mechanical design. So all of those people are in that area. We also do field services. So we have to go out to our reactors and check them, make sure they're performing as required, and tell the regulator that everything is going fine. So we do have tooling for that as well. So that would be a different group. We look at some instrumentation and control. So there's also some areas there that we are working on, as well as codes that we develop. So our computer codes that can assess the life and see if our life can be extended in the reactor core. So those are just a sample of some of the work that we're doing.
Yeah, and you guys have done some life extensions. What's involved in being able to do a life extension?
So a lot of preparation. So when we talk about life extension, it is the refurbishment and retooling. So there is a lot of preparation, a lot of training, and just making sure we have everything in place to do that, working with the client to make sure that they're on the same page, and just all working together and supporting each other.
Yeah. And so I cut you off in terms of the products that are coming up.
Okay.
So what other products do you have coming down the line?
So mostly our focus has been on refurbishment and improving, enhancing those tools to make sure that every refurbishment we do, we learn from and make the next one faster and to the best quality that is required. So that's a big portion of it. Another portion is the new build. So we are still working on our advanced fuel CANDU reactor because there's other aspects of the reactor that we need to develop a little bit further. So those are ongoing. And just some other things that we use in the operation and maintenance of the plant. I can't tell you everything because then I'd give you away the secrets of all our stuff we're developing. You'll have to stay tuned.
Yes.
Yes.
I have to stay in touch so you can bring them to the US.
Exactly. I would love that. Definitely.
And how many versions are there of the CANDU reactor?
So there is our CANDU 6. Which
is modeled here.
Exactly.
Or at least
very
the
good.
control
See,
of it.
you're a CANDU person already. We have the advanced fuel CANDU reactor.
Which is upcoming.
Correct.
Yeah.
We have the enhanced CANDU 6.
Okay.
Which is available now for sale.
And what's the difference?
So the difference between the CANDU 6 and the enhanced CANDU 6 is we've brought in new systems and requirements to meet the latest regulatory requirements and standards. Also, as a result of the Fukushima event, we've incorporated lessons learned from that event, and it is a Generation 3 reactor. Our CANDU 6 was not a Generation 3 reactor. Those are the ones that are currently built. So we now have a Generation 3 reactor.
Interesting.
We also are working in the UK to disposition some of their waste. So we have a CANMOX reactor as well.
Cool.
Mm-hmm.
So you do have like a bunch of different designs.
We do.
And what do you see in terms of the trends of which designs are most favorable to your customers?
So it really depends on what the customer wants from the reactor. The CANDU is the reference plant. So we just add on to that reference plant. So the EC6, the AFCR, and the CANMOX are pretty much all the same, but they have some, like the core and everything, but they have some modifications to address the client's needs.
Yeah. Mm-hmm. And then correct me if I'm wrong, but all of these are like large scale, full facility plants. Do you guys foresee ever developing some sort of SMR type of technology, more of like single unit nuclear versus large builds?
So we don't have an SMR technology of our own. What we are doing is we are partnering with designers that have an SMR technology because we can offer several benefits to them. We have our design capability, but we have also, because we're looking at building SMRs in Canada, we also have that licensing experience because with our EC6 reactor design, we've been through all 3 phases of the licensing process with the Canadian Nuclear Safety Commission, who's our regulator in Canada. So we have that experience and we've learned from it by successfully having the vendor review of our EC6 reactor. So we bring that value to SMR vendors.
Yeah. And how long did it take to push the enhanced CANDU 6 reactor through all the steps of licensing?
I don't know the exact timeline that it took for the vendor design review with the CNSC, maybe a couple years. Okay. I'm not sure. I don't have the exact timeline, sorry.
No, it's okay. You guys work quick here. I'm impressed.
We do. We have a knowledgeable regulator and yeah. So just being in the nuclear environment, I've been really lucky to move around from many different areas and learn many different things. So that's where my knowledge came from. I think it's from interacting with all the people that work here. So I'm very lucky that way. But I do think we need a good mix. I think nuclear has to play a large part because it does provide baseload energy. So we need the baseload. But we also need to have a good mix of other renewable energies as well. But nuclear will always carry the heavy loads.
Yeah. And I guess as we wrap it up, what do you hope for the Canadian nuclear industry and the nuclear industry on a global scale in, the next 20, 30 years? What do you hope to see?
So I hope to see people recognizing that nuclear is safe and that it does provide clean energy, baseload power that we can rely upon.
Great. Kathy Cottrell, thank you so much.
Thank you so much. It was fun. Thank you.